Já si vypnu mikrofon, protože čekám, že ten stream začne řvát.
Hi. I think we are live. So welcome to Cloud Native Meetup. My name is Teresa. I'm from company Revolgy. We are an IT company from Czech Republic, and mostly we are working on Czech and CE region market, from Baltics to Balkan. We have people in Estonia and also in Romania and countries around. We are here to, or I'm here to introduce Ivana and Štefan. There are speakers for today. Ivana is from Grafana Labs and Štefan is from Showmax. So I think we can start. Ivana, if you are ready.
Yeah, I can share my screen.
Okay.
So can you see my screen? Oh yeah, now I can see it.
Okay.
So hello everyone, I am very excited to be here today and to have a chance to talk about the project that I've built, which is my Avocado monitoring system that you can see right next to me. And that is going to be the true main star of this presentation, and about my hobby, which is learning more about the world that surrounds me and building fun monitoring solutions such as my Avocado monitoring system or my sourdough monitoring system. So to start, I would like to share with you how I started with this hobby of mine and why monitoring solution for my avocado plant. So I am a front-end developer at Grafana Labs, and I am working directly on open source Grafana. And Grafana is a very well-known solution for monitoring of infrastructure, and probably some of you are using it to monitor your infrastructure. But during my time at Grafana, I have seen our community using Grafana to monitor a variety of things, living organisms and stuff such as bees, buses, space rockets, beige history, COVID vaccines, coffee, and the list goes on and on. So seeing our community being so creative in their solution, it definitely sparked my interest. But what brought me here is one particular presentation that I would like to share with you. The title of the presentation is Explain Like I'm 5. And in this presentation, Dave is showing how he is teaching Grafana to his kids. And to make kids interested and to make basically anyone interested, you need to figure out what excites them and what they care about. So on the stage, Dave and his kids show how they built trampoline jumps monitoring system, which is just insane. And after seeing this presentation, I was very inspired, and it showed me that firstly, you can monitor basically anything. And secondly, it doesn't have to be hard to create a monitoring solution. So I started to think about what I am excited about and what I would like to learn more about. And honestly, I didn't have to think hard. I just looked around and there they were, my beautiful but very dying plants. I really love them, but I for sure don't know how to take care of them. And especially my avocado plants. So approximately a year ago, I started this experiment where I'm trying to grow a tree from the pit directly. And my goal is to basically grow full-blown avocado tree, but that's very hard. So I knew that I need to step up my game and take things seriously. So if you can't measure it, it's very hard to improve it. And I have personally started with the things that are dying the fastest, my plants. And I think that everyone who is watching this presentation has a hobby, a passion that they would like to learn more about. Maybe some of you are growing chili or brewing your own beer or roasting a coffee, or you like to jump on trampoline. So the goal of this presentation is basically to show you how much fun it is to build these monitoring solutions, how easy it is. And at the end, you are going to learn more about the things that you like and enjoy. So it's triple win situation. And if you already have an idea in your mind, please share it in the chat. Maybe it's going to inspire other people and I for sure like to learn more about fun inspirations and ideas that I could build. But moving back to my monitoring solution, the agenda of this talk is this. So at the beginning, we are going to talk about what does building observability for your plants even mean. Then we will move to building the solution. Then we will set up databases, write the software. And at the end, I'm going to show you my dashboards and graphs in Grafana. And we can also do a little interactive session where we can change conditions in this room and in this plant, so you can see sensors, how they work in real time. And I would start with talking more about observability. Observability is defined as the ability of the internal states of a system to be determined by its external output. So basically, how do we find out, how do we determine how is our plant doing based on its external output? And what are the external outputs? Me personally, when I start the project, I write down all the variables that I could think of that could affect the system that I'm monitoring. In this case, it's on the left, you can see external outputs of the plant. But I have also decided to monitor its surroundings, so environment in which plant is growing. And in this stage, you shouldn't think if it's possible to monitor it, if it's hard to monitor it. This is just the brain dump. You write everything you can think of, and we will figure out the rest later. So these are the things that I have come up with. So for the plant, it's its height, then colors of leaves. Are they turning brown? Are they greener? Number of leaves. Does it have a plant? Does it have a flower? How big are the roots? And so on. And for the environment, it's just basically air, soil, and light, and their condition. So now when we know what are the external outputs, we can move towards building the solution. And to build this solution, we will need development board, input sensors, which are devices that detect changes in the environment. Output, as you can see here, I have decided to add output, which is this LED matrix. And it's showing me how is the plant doing in the real time. And every time I look at the plant, I can see if it's doing good or if it's doing bad. Then we will need some cable, chargers, and breadboards. And at the end, it's the plant stand, which basically holds our monitoring solution together. So let's talk a little bit more about development boards. There's a huge variety of development boards out there. And I have personally I've had two criteria. Firstly, I wanted to use Arduino platform, which is open source platform for easy to use hardware and software. So naturally, I was looking for Arduino compatible boards. And secondly, I wanted to take an easy way, and I wanted my board to so it can basically that it can connect to the Wi-Fi, and it has Wi-Fi module. So I would be able to just send data directly from the board to the databases. So this left me with three options. First one was using Arduino boards. And as the name says, Arduino boards are made for Arduino platform, or the other way around. Arduino platform is built to work with Arduino boards. And that's their huge advantage, because as they are 100% compatible, there is a very low chance that you will encounter any problem. Their disadvantage is that they are on the pricier side. So as you can see, I have here two boards, and the larger one, the Uno V4F, goes for 40 euros, and the smaller one goes for 25 euros, which is more expensive than the alternative solutions and options. Also, if you are choosing Arduino board, just be careful, because many of them don't come with the Wi-Fi. So you have to really look for those ones that have this option, and these two that I have listed here do have connectivity to the Wi-Fi. The second option is to go with boards that are created by the company called Espressif, specifically ESP32 boards. They have different hardware, but Espressif company is doing a lot of great work to bridge the gap between the hardware and to make them Arduino compatible. their huge advantage is that they are cheaper, so they go for around 10 euros, and they are, as I said, Arduino compatible, and all of them have Wi-Fi. I have actually all of these 3 boards, and I'm super happy with all of them, so I cannot recommend them enough. For this specific project, I have decided to use ESP32 Uno R3, but you could use any of these. And the last option is to go with Arduino clone. This is basically the same hardware as Arduino. It's just made by someone else, so not Arduino company, and that makes it cheaper. It's a probably okay option, but if you have resources, I would recommend to go with either Arduino or Espressif, as that way the money that you are spending goes directly to those engineers who are creating these boards and software engineers who are maintaining platform. So you can choose with your money who you are supporting. So moving on to sensors, a couple slides back, we have written down all the variables that we could think of that we could monitor. And if you go to any eShop with sensors, you will get a list of sensors that are available. And basically in this tab, you just match them up. You just pair them up and you find as many matches as possible. I am personally using these 2 eShops that are local here, Techman and Dratex.cz. They are really, really good. They usually ship within 24 hours. I get all my sensors within 48 hours, and I'm a very impatient person. And when I think about the project, I want to build it as soon as possible. So if you are in a similar way, I definitely recommend them. You can always buy sensors from AliExpress or eBay, but you will probably mostly now wait for quite a long time. So here we have our matched up list. So what are we going to monitor? I have bolded those variables and sensors that are part of the solution that you can see here. So for the plant, we are going to monitor its height with ultrasonic distance sensor. For colors of leaves, I have found a sensor that is able to detect colors. I also ordered it and tried it. However, it's very unreliable because it relies on the lighting conditions in the room, and they change over the day. So the readings from the sensors were the variability was just too big. So it's not part of the solution yet, but I'm still figuring that out. For the number of leaves, and if it has flower, you can use camera and then do it manually, or maybe train your model to do it for you. For the environment, I'm monitoring air temperature and air humidity. I have light sensor that tells me more about light conditions. I'm using soil moisture sensor to figure out if the soil is wet or dry. And I have also found solution or sensors to monitor nutrients in the soil and pH, but those were on a pricier side. Usually the sensors are around 5 euros, but these were around 100 euros or 30 euros, I think was the NPK sensor. So I have decided to not use it in my solution. So let's go over what do we need for the whole solution. We have talked about the development board, sensors. As I mentioned, I have also output sensors. Then we will need cables. So we will use DuPont cable to connect sensors to the board, charger, and breadboard. I will talk a little bit more about breadboard in the next slide. And plant stand. Or basically, you don't need plant stand. You can go wild and just design and build whatever solution you like. If you have 3D printer, you can get really fancy with it and make it very, very pretty. So the options is yours. So here's how we are putting it all together. On the left, you can see actual image from under this box. On the right, you can see the wiring diagram. Unfortunately, in wiring diagram, I wasn't able to find the board that I was using, or in the software where I was doing this wiring diagram, I wasn't able to find the specific board that I am using. Therefore, I am using Arduino Uno. So the pin numbers are different, but other than that, it's pretty accurate. And to just walk you through, here is LED metrics. We have here soil moisture sensor, ultrasonic distance sensor. This is the sensor for light conditions, This is for air humidity and air temperature. And here is the breadboard. And as you can see, we have more inputs and outputs than we have grounding and power pins. And that happens if you have a solution with a lot of inputs and outputs. So we can use a breadboard in a way where we connect, for example, in this case, grounding pin with the breadboard, and then everything that is in that row is going to act as that pin. So we can get extra for grounding pins and also extra for power pins. Here I have couple close-up images of the solution. As it's dark and you probably cannot really see it. So as you can see, here it is. And also here is my experimentation with the color detecting sensor, which isn't part of the solution yet. So we now know what we need, how to put it together. So let's set up databases. And some people like to start to write the software and then move to setting up databases. I like to set up databases and then move to writing the software, so I don't need to switch the context. I have decided to store my, InfluxDB as a storage for my metrics. InfluxDB is open source project, very popular option for IoT projects. And I have personally decided to take an easy way and not to spend too much time on setting up databases and use their cloud solution. They have a free plan that is rate limited. However, we are producing we are not producing much data, so there is absolutely no problem with that. And an advantage of the InfluxDB cloud is that they are using here their new querying language, which is called Flux. And it's the functional data scripting language. And I have seen some people doing some fancy stuff with it, even machine learning, but I didn't get there yet. So that's Influx. And this is more or less my experimentation. I have decided to save metrics or data from my sensors also in form of logs. I'm using Loki as a database. We were just talking that Marco, my colleague, was here approximately a year ago, and he was talking more about Loki. So maybe some of you are familiar with it already. But again, for simplicity, I am using Grafana Cloud managed solution, and setting up is very easy. And you have free plan with up to 50 gigabytes of data, or 50 gigabytes of logs. And I have looked how much logs I am producing, and it's like 0.002 gigabytes a month. So definitely that's more than enough for a lot of monitoring solutions. And why I decided to set up also a logging database, I like the option that I could add more information in a text form. Which is, for example, in my case, the status of the plant, which is the same status as is displayed on the LED metrics. So our databases are set up and running, and we can move towards writing the software. So as I mentioned, I wanted to use, and I'm using Arduino platform, which is electronics platform for easy to use hardware and software. Arduino natively supports programming language, which is called Arduino programming language. And it's just basically a framework on top of C++. And what Arduino platform does is that it compiles the code and it uploads it to the board. So you have two options when it comes to the Arduino IDE. If you have Arduino board, you can use the online Arduino editor. However, we are using ESP32 board, so we need to install our Arduino IDE, which is no problem at all. And we are actually going to now move to my VS Code. I will walk you through the code. We will do a couple of changes, and we will use Arduino IDE to upload it directly to my monitoring system. So let me jump here. So program written in Arduino programming language is called Sketch. Sketch has .ino extension, and I will walk you through the code of this program. So at the top, we are including our libraries and configuration file. Regarding libraries, Arduino has a great community, and there is basically a library to work with any kind of sensor. So it's very easy to set up them and read data from them. Then we are defining our variables, so NTB client, lock-in influx client, some sensors, LED visualization. We have here functions to set up a Wi-Fi using the Wi-Fi library. So again, very easy. We have here two functions, submit to influx and submit to Loki, where we are using the HTTP client library, which basically sends the post request with the body that it's in the form that that specific database is expecting it. So that's that. And we have here a couple of more functions, for example, display the state, some wrapper functions to get measurements from some of our sensors, like soil moisture sensor, height. And here comes the part that is kind of tricky. So I have here this ultrasonic distance sensor, and it works very well when the plant is small, because it has small leaves and they are wider, and it works very well with a big plant that has big leaves. But it works terribly with this kind of plant because it cannot really shoot it correctly with the ultrasonic wave. Therefore, I had to do this a hack where I am semi-oftenly updating manual current height, and that is used instead of incorrectly read height of the plant. However, I am planning to add this touch sensor and basically figure out it in a way where I will just measure plant maybe once a day, once in 2 days, and I will do it by pushing on this sensor, and I will make sure that I have a correct height for that. So that's my hack for this kind of awkward height of the plant. But as soon as it's going to be bigger, it's going to be without problems again. We have also here function to get light value and do some computation to get it in lux. And last two functions are to check if readings failed. If any of the sensors produce invalid result, we can return early. And we have here function to basically create and display state. So those were the less important functions that are going to be part of the very important functions. So sketch, every sketch has to have two functions. First one is called setup, and the second one is called loop. Setup is run just once, and it is when program starts, and it's a perfect place for setting up pins or initializing library. So for example, we are here setting Wi-Fi and initializing our sensor. For the loop is something like a heart of the program, and it's run over and over. And this is the place where we are reading the measurements from our sensors. So you can see we are reading humidity, temperature, soil moisture, height, light conditions, and then submit it to influx. I have personally decided to send this data every 2 minutes because the plant is pretty static. There's not that much that happens within 2 minutes, but as I'm going to show you some dashboards and some graph, I think it's going to be more fun to see them more interactive. So I'm going to change the interval to 5 seconds. And okay, let me just move here. And here we are in our Arduino IDE. And we will, so we can see, so we can check here that we have correct board, correct upload speed, and we can upload this program to our board. And while this is uploading, we can slowly, so it needs to compile first, and then it's going to be uploaded. And while it's doing, we can move here, which is my Grafana dashboard with the data from the Avocado, besides others with the data from Avocado sensors. So let's open this specific dashboard. Let's see, it's uploading. So I have here dashboard and panels with the readings from the Avocado monitoring system. This is its current height and soil moisture. So my soil was wet, was dry yesterday, so I watered it, so it's wet now. This is the location of the plant. And here we have readings for the past 7 days. So you can see the temperature is slightly rising. The height, this you can see here, this is the place where we were actually measuring the height. But here, so is it 3 days ago, we got into this awkward phase where it is not, it's not detecting its height. So I'm just looking forward when it will be so big that we will be able to measure it correctly once again. Heat index, humidity, soil moisture. What I learned is that they recommend to water avocado, like a smaller avocado plants, every 1 to 2 days, but they say that the soil should dry out a little, which doesn't happen for me. It dries out every 3 to 4 days, so I have changed my watering habits. And also my big learning moment was that my plant was actually located next to me, and I thought that it's getting enough light. But this was the one day, the first day when I added my light sensor, and I learned that my plant is definitely not getting enough light. So I have moved it to the window, and as you can see, it's getting so much more light now. So I think it's going to grow faster, and as you can see, also it correlates with the temperature because by the window, it's warmer as the sun is shining there. And here we have logs related to these metrics. And what I like to do is that you can just zoom in if you have any interesting data or change in data, and you can see logs that are related just to that. So you can see like right away the measurements and the status of the plant. So this was uploaded. Okay, we can check if it's working. Yes, we are getting new data. Okay, yeah, that's working. So let's move to my second dashboard and last dashboard, where I have a little more like selected and group data. So I have here a master graph, but I have here logs that are divided based on the status and on the light. So this is the very similar situation as I was showing you before. When I zoom in, I have an like exact overview on what is the condition with the plant, like light condition, and how the plant was doing. I have here also a table with all of the results. I am using Grafana's feature, which is relatively new, that it changes the background of your table based on the values within the table. So it's automatically colored based on how, what is the temperature. And here we have also values. We make it for 2 days. So we have average values for when the plant is wet and when the plant is dry. And yeah. So we have checked the graphs and dashboards, and I have already said what I learned. I learned that in winter, my plant really needs to be by the window, water less often, and there are still forces, specifically bugs, beyond your control. I had a beautiful plant that was always happy, but it died because of bugs infestation. So there is always something that you cannot predict, and you should be okay with it. And last thing is, let's monitor all the things. I would really love if if you decide to build some project, if you would tag me, send it to me. I'm always looking forward to see fun projects and learn more about it. And that's all for me. Wait, I promised a little. I'm just thinking. I promised a little demo about like how the readings from sensor changes, and I have actually added here a plant that has a very, very dry soil. So I'm not sure if we have time. I can show it, but I don't have to.
We have a time. No worries.
Okay. So let me just go. Back to the Explorer. We can do live tailing. Also, plant ID is the ID, is the date when I ate the avocado and started growing this this plant. So it's over a month old now. And so we can see here current values. And I was thinking about just switching this. I'm not sure if you see. I hope you can. I just added it to my really dry plant, and then we should in a couple of seconds see. You see the status is dry, so it basically almost immediately shown or change the values of the readings from the sensor. And also I was thinking how much light. I can turn off a light here. Maybe it's gonna do something, but I'm not. No, it's probably not gonna because I have light far away. So I think this is going to be the only demo that I will do. But yeah, that's it.
Okay, thank you very much. It was very interesting. We have one question from the audience. Peter Sentner asked, what do you plan to build next, Ivana?
Yeah, so that's a very good question. I have a bunch of sensors. I have a new obsession where I'm just like buying sensors and figuring out like what I would like to build with them. I have a sensor that can detect fire. So I'm thinking something about the like monitoring candles because I really like the candles. And yesterday when I was going to bed, I forgot about it. So it can be kind of like a safety monitoring solution that would tell me how much candles I'm burning and also make sure that I won't die in fire.
Okay, another. Stefan asked, why did you pick Influx and not Prometheus?
That's a very good question. I think Prometheus is a very good solution for monitoring of infrastructure and very oftenly used. However, for me, it was so much easier to work with the Influx as you can basically just push your metrics. So the push factor or like the push strategy is definitely, I think, easier for when you are working with Arduino. There are also no any like or at least I haven't found any Prometheus exporters that I could use, and therefore I think it was better option for me.
And Daria, she was our speaker also at Meetup. Hi, Daria. She is asking if it's possible to have a look at the JSON output of your dashboards and if you share it somewhere.
Yeah, so I am not currently sharing it anywhere, but I can definitely send it to you. I was even thinking about making this dashboard public and have it accessible to anyone. So I will definitely figure out something, but I will for sure send you the JSON.
Okay. Marek, do you have any question?
No, Stefan just took mine, so, you know, I didn't have anything else. But if you have some code that you want to share, we have a GitHub repo and we can put everything there if you're interested. Thank you for the talk.
Yeah, also I have, so yeah, it was on my last slide. I was just thinking, I added my social media and GitHub, and I'm also posting or sharing all of my code when it comes to this monitoring solutions to GitHub. So it's there. And on my Medium, I'm sometimes writing about like step-by-step guides on how to build this system. So when I was, for example, building my sourdough monitoring system, by the way, hands up if anyone else jumped on a bread baking wave over this pandemic, because I started to bake the bread, and I started to monitor my starter. So yeah, it's on my Medium. That's what I wanted to say.
Perfect.
Skiri ask if you can put it on pasta bin, please. So maybe you can think about it. And Honza Sechovec, he's from Revolgy also. He has a question if you consider using camera and Jetson Nano and do visual analysis.
That's a very good question. I have, as I mentioned, I have the list of all the variables and all the sensors. So it's definitely out there. I'm looking forward to build this is Avocado monitoring version 2, but I'm always looking to pimp it up and make it better. So that's definitely on my plan. So yeah, but no specific plans yet.
Okay.
But yeah, I'm as I mentioned, I also on Twitter, I'm sharing my project. So when I will add it, I will definitely write about it. So if you're interested, you can check it out.
Okay. So let's put Štefan on a stage. Hi, Štefan.
Hello.
So if you have guys any questions to Ivana, please put there and write them in the comments. We can handle it later after Štefan talk. Štefan is CDN Engineer from Showmax. Am I right?
Yes.
And he will talk about logs and Akamai. So I will jump off the stage, and stage is yours.
Okay, thank you. I'm still waiting for the slides to appear, so in the meantime, I will just look awkwardly at the screen. Nice. So yes, this talk is about using AWS to process Akamai logs. I will talk a little bit about myself, about the company, and about what we do and why we did it the way we did. It's just a lightning talk, so don't expect too much depth. However, if you have any questions, there will be a lot of time in the end to ask anything that you want. As everybody else, I'm also on Twitter, so if you remember anything that you wanted to ask but forgot to, just ping me at Twitter and I will happily answer whatever questions you might have. So first of all, a little bit about myself. You can see my name. I'm Štefan Šafár. I work on the CDN, and the CDN stands for Content Delivery Network, which is going to be a little bit of a focus here today. We deliver tens of gigabits per second in South Africa and also other African countries, but most of our user base is based in South Africa at the moment, though it is changing quite fast. Of course, you see me here because I like clouds, but I also like security, privacy, monitoring, and networks. Hence why I asked about Prometheus, because I'm a huge Prometheus fan. As you can see if you would see my disk directly, but I also have these beautiful Prometheus coasters to use. So what is Showmax? For those of you who don't know or have never seen the company, it's an online video streaming service in Africa. We have a huge catalog of video on demand titles. We have our own productions and we stream a lot of African shows, but we also buy rights from American companies and Hollywood titles. So it's a mix of local content and American content mostly. We have teams in EU, mostly in Czech Republic, and in Africa. Our service is based on microservices, and it has been from the start because we are quite a young company. I think we were founded in 2015. Right now, we are running most of our stuff in a Nomad cluster, which was custom made and custom run. But we are in the process of migrating to Kubernetes setup in AWS, and it's based on EKS. And when I joined the company, I was really surprised that we log everything, and we log ridiculous amounts of data. So our current Elastic cluster is around 100 machines. They have around 6 cores, 64 gigs of RAM each, and something a little bit above 1 terabyte of drive space on each and every one of them. So it's getting a little bit ridiculous. And I'm pretty sure the previous speaker would be happy to hear that we are also migrating off to Loki. So yeah, we are going to get rid of most of the logs in Elastic and only use it for stuff that makes sense. So about content delivery network. We have a mix of our own machines and third parties. That is because there's always a trade-off between price and performance. And for some, if you want to run your own content delivery network, you must have your own network equipment, your own machines, your own network cables, your own hosting, and you have to manage to connect to all of the exchange points in the places where you want to operate, all of the network interconnections, and so on. So the bill can get quite high. However, in the long term, if you can get the price much lower than if you buy a retail product. So it's a double-edged sword, because sometimes it's much better to use an off-the-shelf solution like a third-party CDN, like Akamai, AWS CloudFront, Cloudflare, or whatever else you can think of. But it's sometimes it's better to have one thing, sometimes the other. So we usually rely on the Akamai network at the moment for low-traffic countries. So those are countries where we don't have a physical presence yet, or we don't want to have it for whatever reason. We use it as a backup. So if any of our machine misbehaves, we can switch it on as a backup, and people shouldn't be able to tell the difference. Just the company will notice it on the bill. And we also use it for live content, which is much better served from huge CDN providers, because they're easily scalable to a large amount of users. And you will see why this is important in one of the slides in the end of this presentation. So Akamai being a CDN, it evolves. It's one of the largest, or maybe even the largest CDNs in the world. They used to do, for example, updates for Microsoft throughout the world. I'm not sure if they still do, but just the sheer amount of traffic that they are able to handle is really impressive. So they, among the years, they had multiple different log delivery solutions, and sometimes they were better, sometimes they were worse. But right now they are offering two main services. One is called Log Delivery Service, which is basically just an SFTP or FTP of logs to your storage. So you run your own server with an SSH, and they upload all of the logs once an hour, give or take. They offer lots of different formats and options. The downside is that you need to parse it, so it's like parsing your own logs. One of the newer offering that they have is called DataStream, which is much better from my point of view. Its latest offering, it supports almost real-time logs, which means whatever happens, it's in a minute it should be uploaded to your server, which is super nice because you have near real-time graphs and monitoring. And it supports S3, which is really nice because we're migrating to AWS, so it just so happened to be an ideal candidate for us to try out. So right now, or before we implemented this solution, and we still use it for some of our older setups, we used Log Delivery Service to deliver all of the logs to our server and then parse it there. But we are in the middle of migrating to the DataStream approach in all of our logs. And the other awesome thing is that it's already JSON formatted, which is great. So you can just take it and push it into Elasticsearch, and it should be fine, right? However, it's not as easy because every machine that serves your content which could be tens of thousands of machines, or in our case, it's hundreds of machines, of Akamai Edge machines. Every machine that serves traffic from you in the given minute creates a small gzipped JSON file and uploads it to S3. So you can see it gets really, really overwhelming in a really short time. Also, the format is a little bit weird. I don't know why they do this, but as you can see, the content type application/dash, I don't know why the content type here is at all. I don't know why the /r/n, the new line, is here. However, it is there, so you have to do a little bit of cleanup for it to make sense. Also, they use something called cache H, and I would like to tell you I know what the fields mean, but I don't. You can Google it, you can find it in their documentation, but we decided it's better to split it up into some more actionable items than to leave it as is, as a string. So what we actually did. So we created a solution. As you always do, you get whatever Amazon offers you and just stick it together so it makes sense. So Amazon sends all of their logs into our S3 bucket. That then triggers a Lambda function, which we wrote in Python, which surprisingly isn't the costly or the costliest thing within the whole ecosystem. It unzips the data, patches up whatever stuff that we need to, like we saw here, and splits it up into multiple values for the cache hit numbers, and then it pushes them to Kinesis and then to Elasticsearch. Kinesis is a service for those of you that don't know it. It's basically a queue. So you just push something in and it pushes it somewhere else. The nice thing is that it also acts as a buffer. So if, for example, we would overwhelm the Elasticsearch service, the data would still sit in Kinesis for a while and give us plenty of time to fix whatever issues we would have with the Elasticsearch service. Yeah, I would also like to show you one of the records so that you can appreciate the ugliness. Wait, okay. Is this readable? Can anybody tell me, please? Okay, I will keep thinking that it is readable. So you can see a lot of data here, and by the way, you can select and pick what data you want in your logs and what you don't want. We were mostly interested in all of the performance data. So we have the basic stuff, when it happened, HTTP port, client IP, which I purposely put away so we don't have to, so we won't DDoS our clients or whatever. You can see the method, HTTP version, all the fun stuff. And as you can see, the content type here is in this horrible format, which we needed to fix. Other, which is super weird, is response length. As you can see, it's content length. This is colon, space, a number, and a new line, which is just horrible. So you have to fix all of that to have some meaningful data from it. Yeah. So they also give you some network performance and network measurements, like bandwidth was 5,000, which is 5 megabits. And yes, the unit is in kilobits per second for some reason. Throughput is some measurement of their CDN, which means this should be a good line. There's also some other stuff that is basically not as important, but you can see the autonomous system from which the request came, and the geo data and cache status. So I have a few screenshots here for you. If you know Kibana, you probably have seen similar stuff. Just so you can see the scale, it's pretty large. It's 154,000 hits in 15 minutes, which is not so bad. You can also see that thanks to this, we can also do some geo splitting of the data into different buckets. You can see it's 21 gigabytes served from this host for is it terabytes? Wait, kilobytes, megabytes, gigabytes. Yeah, 21 gigabytes, 4 gigabytes, and yeah. So you can see all that here, and you can see the top 3 countries there. When I switch it to another graph, from this one, you can see actually the time to serve clients. And you can clearly see that these red and green ones are much better behaved than the blue one. And that has a really nice explanation. And that is that these two are live channels. So it's basically something like watching your TV, but over the internet. So something like you probably know like the O2 TV or something like that. So they will probably be much better cached than whatever people will watch on the video on demand side, because that will have a much higher probability to need to contact the backend. So these differences are completely normal. And the last graph that I want to show you is this. As you can see, there's also 3 channels or 3 host names. The blue one, which is almost invisible here at the bottom, is the stuff that we regularly send from the video and demand part. The green one is one part of the channels, and the red part is another part of the live channels. But as you can see, there was some sport game which created a huge spike of demand, and another one here. This is like I would say like 7-8 times higher gigabytes per second than in normal circumstances. This peak was around 150 gigabits per second, which is kind of impressive. So my final thoughts on this. I have to say I was not so well versed in AWS. So this was my first, at least a little bit interesting project that I did in AWS. And for the first few days, I was battling with VPC and all the security settings during the setup of the POC. That was entirely my fault. I could have asked someone like Marek or someone else who understands all the stuff, but because I'm stubborn and I wanted to learn, I stumbled a little bit. The service itself is great. It's easy to start, easy to scale. As anyone who uses AWS knows, the bill also scales the same speed as the machines. I had quite a few issues debugging lambdas. I still think that the interface is quite cumbersome. If you encounter any issues, it gets rather complicated. But also, it's super useful that you can plug lambdas basically in any part of the stack that you want. Everywhere on the way, it's possible to run other lambdas to do some more data manipulations whenever you need to, which is super nice. Another thing that when I did the POC, I didn't set up automatic deletion for the old stuff. So in the end, I manually deleted all the data, which was a horrible experience. It took me like maybe 2 hours, and AWS kept invalidating my login cookie, so I had to log in again and again, and open the website again and do it again, and run the deletion again, and so on. And it was horrible. I know I could have done a script to do it. Hindsight is 2020, right? But if I just kept if I just set up a policy to auto delete all the stuff, I would just need to wait a few days, and they would be gone. And the last thing, keep S3. If you want to implement this at any time or place, you need to keep the S3 and other services in the same location, because if you don't, it will incur more and more ridiculous costs from the AWS. And that's basically it. If you have any questions, please ask.
We have a lot.
Okay, I'm listening.
So the first one is from Ivana. If you have any plans for using Tempo?
I have no idea what Tempo is, so I hope I will not embarrass myself.
No, I was just following up on what you said, that you are switching to Loki, and Tempo is our tracing backend, and it's basically, there is a saying about Loki, it's like Prometheus but for logs, and Tempo is like Loki but for the traces. So
okay,
that was just following up on that.
I don't know, honestly. It might be the case because our the migration is driven by another team, not by CDN, obviously. So I'm pretty sure some of them are in the chat, so maybe they could answer the question, but I don't know.
Also,
but I will definitely take a look at it.
It's a very new project, Joseph. Why
So it's not production ready.
I think we use it. We've been using it at
I'm
production.
just joking.
It's very production ready.
Okay.
So another question from Pavel is, have you looked at Amazon Athena to query your logs directly?
No, I didn't. I didn't know that it exists.
Now you know. There's going to be a lot of questions like this, probably.
Okay. Bring them all. Show them what else I don't understand.
So another question is, Štefan, how do you manage your AWS resources?
Okay, so for this project, when I was setting it up in the beginning for the proof of concept, I did it manually. First of all, I wanted to learn and take a look around in the console. And for the production part, there is another team who took care of it. When we set it up, we finished the lambdas. We knew that it worked. They set it up themselves. The team that is migrating our Nomad stuff to AWS, they have everything in Terraform and Terragrant as well, because Terraform by itself wasn't enough. There are talks about switching to some other stuff. There's a lot of things changing all the time, because once you encounter some issues that you can't solve with the current setup, you always look for alternatives. So right now it's based mostly on Terragrant.
Perfect, thank you. Any other question? Oh yeah, there's another one. What is the latency from request time to Elastic?
That's basically seconds. I would say like 10, 20, 30 seconds, give or take.
Perfect.
I didn't measure it directly, but I can see the logs appearing almost the same minute, so it shouldn't be more than 30 seconds.
So that's all, I think.
Okay.
Anybody else from the team have any question?
No.
Then that's it.
That's it. So I would like to thank you, all of you guys, especially to speakers that they were so kind and talk to the monitor and laptops again. And I would like to also thank you, our audience. Even if we are not seeing each other offline and we can do beer in Ježkové Voči after the meetup, I'm very happy that you are here still with us. I would like to also thank you, Marek Bartik, and his pipe tail, because he's cheers. He's really good guy, and he's helping us with Cloud Native Meetup almost like 2 years, right? Yeah.
I think it's gonna be 2 years already. Yeah.
Yeah.
We can celebrate again.
Yeah. Maybe when zombie apocalypse ends, we can do some beers. So that was it. I will send you some feedback form. I will put it to the comments. Probably tomorrow there will be recording on YouTube channel. Please follow us on Twitter and on meetup.com. Be part of our community, so you can be notified after a month or so when we will do another meetup, hopefully offline, but we will see. So thank you and have a nice evening.
Thank you, and hope to see you next time, possibly at the end of February.
Bye.
See you.
Bye-bye.